Hello, welcome to University. Today we'll be solving a problem on vectors. For the purpose of we having the entire board to ourselves, the question will be displayed on the screen there. All you have to do is to write it out somewhere and then resume the video. Alright, let's dive into it. The question says, four vectors r equal to ai plus bj, where a and b are positive constants. Vector s is equal to 2i plus j, vector m equal to 3i plus 2j, and vector n equal to I plus j. And they are such that the magnitude of r is 3 times as s and is parallel to the vector m minus n. That's the vector difference. Find the value of a and b. Then the second question there is calculate the magnitude and direction of r minus s. So the first we have to do is to write out our vectors. R equal to ai plus bj, s equal to 2i plus j, m equal to 3i plus 2j, and n equal to I plus j. So let's first of all write out the conditions that were given for this. The first condition says that the magnitude of r is equal to 3 times magnitude of s. The second condition says that r is parallel to m minus n. And then the questions find a and b. Find a and b in vector r. And then the second one says find the magnitude and direction of r minus s. So the first we have to do here is to observe the conditions. They say that r is parallel to m minus n. But first of all, what is m minus n? What's the vector difference there? We say m minus n equal to, and we have 3 for the I component minus 1, plus then for the j component we have 2 minus 1 j. If I have to subtract this, to give you 2i plus 1j, which is still j. That's m minus n. And it was said that r is parallel to this. So we can state that, let's state the condition, knowing r is parallel to m minus n, and put that in the brackets. We can assign the value of k to multiply this, and to look like r equal to k m minus n. So r equal to the value of k multiplying what was our m minus n, that's 2i plus j. So finally r equal to 2ki plus kj. Let me call this equation 1. Now, this was first of all given in our question as, that's the value of r here, as a, let's say recall that r equal to a I plus bj. Now that simply means R is still R, so we can equate them. And if we compare the value of R, we can see the coefficient of R here is A and the coefficient of R here is 2k. So we can say A is equal to 2k. And the coefficient of J here is B, the coefficient of J here is K. We can say B equal to K. Now that we've done that, we can proceed to find the magnitude of R. So we say for the magnitude of R, it will be equal to, remember that R is, using this here, to be equal to 2k squared plus k squared. And that will give us this 4k squared plus k squared. That will give us 5k squared. And then this will come out, the k will come out of the square here to become k root 5, the magnitude of R. Now let's proceed with the next condition. It says that the magnitude of R is 3 times the magnitude of S. Before we talk about 3 times the magnitude of X, so what is the magnitude of X? So let's go for magnitude of S. What's our S there? That's 2i plus j. That will be 2 square plus 1 square. And I believe this will give us just root 5. So let's bring in the condition. The condition says that R, the magnitude of R is equal to 3 times the magnitude of S. That means it's same as 3 multiplying, what's the value of S? That's root 5. 3 root 5. And what's the value of the magnitude of R? K root 5. K root 5. So if we are to compare the coefficients of, let me put it here, compare coefficients of root 5, you can say K is equal to 3. K is equal to 3. Let's wipe this side off. Remember, we're still looking for the value of A. We're still looking for the value of A. Now, watch what is happening. We have found K as 3, but we know that A is equal to 2K. So we can simply say A equal to 2K. That simply means 2 times value of K is what? 3. That means A is equal to 6. B is equal to K. So it's equal to 3. That means the value of R now becomes, before it was A I, so now it becomes A is 6I plus, before it was BJ, so now it's 3J. So this is the value of A and B, and this will be the value of R. So the next question says, calculate the magnitude and direction of R minus S. So we have our R here, we have our S. Okay, we've not solved for S. Let's solve for S now. R minus S rather. R minus S will be equal to, let me write my S here for those that cannot follow because we've wiped the side. So this is S is 2I plus J. So our R minus S, this question 2, R minus S is equal to, for our I component, 6 minus 2I plus 3 minus 1 J. which is equal to 4i plus 2j. Now with that done, we have to also find the magnitude of this. So we say magnitude of r minus s equal to the square root of 4 square plus 2 square, which is equal to 4 square is 16 plus 4. So we have here the square root of 20. In a way, we can still simplify this to be 4 will be rooted out to give us 2. That's 2 roots 5. So this is the value of the magnitude of r minus s. They also say that we should find the direction of r minus x. So we can say for the direction of r minus s, that will be equal to tan theta equal to 2 over 4, which is equal to 1 over 2. So theta will be equal to the tan inverse of 1 over 2. So theta equal to, let's press for the sine inverse of 1 over 2. That was 26.6. So this is how you answer questions that look like this in vectors. Please take note of the conditions given. If you can apply the conditions appropriately, you will get to answer correctly. Thank you so much for watching this video. Please do well to like, subscribe, share, and comment, ask any questions as related to this, and I'll be here to give you your answers. See you in our next clip.